Welcome to Homework Lib.
To draw the Lewis structure, we first need to count the number of valence electrons. Beryllium has 2 and each fluorine has 7, giving us a total of 16 valence electrons. If we bond each fluorine to beryllium and then give each fluorine 3 lone pairs, we would have used up all 16 of the valence electrons. With only 2 electron groups surrounding beryllium, both being bonding electron groups, then this would have a linear geometry, a linear molecular geometry. Then for NOF, if we bond N and F to oxygen, we have a total of 18 valence electrons, 5 for nitrogen, 6 for oxygen, 7 for fluorine. And then we give fluorine an octet and oxygen an octet with 2 lone pairs. We only have 2 remaining lone pairs for nitrogen. So that's going to require oxygen to share one of its lone pairs to give us a double bond. We now have 3 electron groups, one of a single bond, one of a double bond, one of a lone pair. 3 electron groups with 1 as a lone pair gives us a bent molecular geometry at 120 degrees. But I actually think this one is ONF rather than NOF because this gives us formal charges of 0 on everything, which is more reasonable, but we still get bent at 120 degrees. Then antimony has 3 valence electrons in group 3A. Chlorine has 7. There are 3 of them, giving us 24 valence electrons. If we bond chlorine, let's see, actually antimony has 5 valence electrons. Oops. So that's going to give us 26. If we then bond each chlorine to antimony and then give each chlorine 3 lone pairs for an octet, that's 24 valence electrons. Then we have enough to give antimony a lone pair, so it has an octet. Now we have 4 electron groups, 3 of which are bonding, 1 is a lone pair. When we have 4 electron groups, 3 bonding, 1 lone pair, then that gives us a tetrahedral electron group geometry, and we get a trigonal bipyramidal molecular geometry. Then for the last one, we have SiHBr3. Si has 4 valence electrons, hydrogen has 1, bromine has 7. There are 3 of them. That gives us a total of 26. We then bond the 3 bromines and the 1 hydrogen to silicone, each bond requiring 2 valence electrons. And then we give each bromine 3 lone pairs. That would have used up 26 of the 26 valence electrons. So now we have 4 electron groups, just as we did here, but they are all bonding. If they are all bonding, then we have a tetrahedral molecular geometry. I hope that helps.